Good morning, students. Welcome back. Now, today we are going to discuss chapter number 4, moving charges and magnetism. Okay, here we will take the first topic, that is magnetic force. What is magnetic force? Before that, we will see what is electric force, right? It is there in chapter number 2. Before that, let us see what is electric field. Okay, electric field is symbolized as E, and it having equation E is equal to KQ by R square. From where it comes? It comes from the definition of electric field, that is E is equal to repulsive force acting, that is F per unit charge Q. Put the value of K, so you will get Q by 4 pi epsilon 0 multiplied by R square. So this was the equation of electric field. E is equal to KQ upon R square. By using this equation, you will find the force, that is F. Which force? F is nothing but electric force. So because of that reason, put F E. What is E? E subscript stands for electric force and is equal to, take Q on this side, so you will get Q multiplied by E. Give it equation number 2, and this is equation number 1. Okay, so this is the electric field, its equation, and this is the electric force. Electric force acting on a charge, but this force acting on a charge, not only that, electric field produced due to the charge, but what is the main condition? This charge must be steady. Got it? Means steady charge produce electric field. Okay? And this electric field is not instantaneous. Means electric field produced by the steady charge depends upon, right? That means electric field depends upon time. Okay, this electric field consists of energy and momentum. Okay, this was there in chapter number 2. Once again, electric field is due to the charge, but charge must be a steady. Means if electric charges are steady, then it produces electric field, and it is given by the equation number 1. Similarly, if the charges are steady, then the force acting on it is given by F subscript E, means it is electric force, and electric force acting on a charge is given by equation number 2, that is Fe is equal to Q multiplied by E. Okay, so let us see what is magnetic field. Okay, magnetic field, it having symbol B. Okay, again this is a vector quantity. So electric field is symbolized as E and magnetic field is symbolized as B. Okay, so let us see. This magnetic field is produced when, suppose this is a charge, it is steady, it produces electric field, but when this charge is moving, then this moving charge produce magnetic field. Okay, as we have seen in chapter number 2, electric field obey the law of superposition principle, means it obey the superposition principle. Same way magnetic field is also obey superposition principle. What was superposition principle? Let us say. So it is superposition principle. Okay, suppose for our conveniency, this is a one charge. When charge is moving, it produces magnetic field. But if more than one charges are produced, then magnetic field produced by charge number 1, suppose it is B1, magnetic field produced by charge number 2, suppose it is B2. Similarly, suppose there are n number of charges, so it having magnetic field Bn, right? So according to the superposition principle, there is algebraic sum of magnetic field produced by two or more charges, means magnetic field B also obey the superposition principle. So according to the superposition principle, it is here. That means magnetic field produced by one or more charges, then the total magnetic field is algebraic sum of magnetic fields of individual charges. Clear? Now let us see. If charge is steady, it having electric field, it having electric force, but when charge is moving, then moving charge produce magnetic field. In which direction it produce, that we will see later on. But if there is a electric field, then there is electric force. Now we have magnetic field, so there must be a magnetic force. And this magnetic force is symbolized as F for force and M for magnetic force, right? And that magnetic force is given by Q in bracket V cross B. Give it equation number 2. Okay, so what is magnetic force? Magnetic force is equal to Q, that means charge which is moving, V is the velocity of that moving charge, and B is magnetic field. So you have to write, what to write? That is, what is Q? Means here Q is nothing but it is a charge. What is V? V is nothing but velocity of that moving charge, and B. What is B? Exact. B is nothing but magnetic field. Okay, this equation we have taken from the reference book. Okay, why? Because with the help of this equation, we are going to find the unit as well as dimension formula of magnetic field. So from this equation number 2, make a subject B. So B is equal to, take QE downside, so B is equal to F. It is simple, nothing but force, Q multiplied by V. F, obviously it is a force, so it is Newton. Q, electric charge, was invented by Coulomb, so its unit is Coulomb. And velocity, exact, meter per second. Take second upside, so we will have Newton, then second upon Coulomb into meter. Okay, this is SI unit, means SI unit of magnetic field, which is symbolized as B. Again, with the help of this equation, make a subject B. B is equal to Fm. Take Q and V downside. Put simple. Force, Newton. Q, electric charge, Coulomb. Velocity, meter per second. Take second upside. So you will have Newton, second, Coulomb into meter. Right? It is SI unit of magnetic field, but it was invented by Tesla. So this is also known as Tesla. It is a name of scientist, but if you want to write in a symbolic form, then you have to put T. That is Tesla. And this Tesla is a non-SI unit. Clear? So, SI unit system, in SI unit system, Newton, second, Coulomb, meter. But it is also known as Tesla. There is a one relation between Tesla and one more unit is there that we will discuss later on. Okay? Then its dimension formula. So we know very well Newton, that means force. Force we have prepared well, isobar minus exact MLT, isobar minus, okay, second means T1 upon Coulomb. Coulomb means A1 T1 multiplied by meter. Meter means L1. So you will find that here T1 get cancelled out, L1 will also be cancelled out. So we will have the dimension formula of magnetic field is which, that is M1, L is cancelled, T minus 2 is already there, that is T minus 2, A will go up, so it is A minus 1. But if you want to write in that MLT format, then here you have to put L0. Okay, so this is the unit, Newton second per Coulomb meter, and it is its dimension formula. For your convenience, we are going to highlight that unit as well as dimension formula. So it is Newton second per Coulomb into meter, or simple, it is known as Tesla, and it having dimension formula M1 L0 T minus 2 A minus 1. Have a look. Okay, Now let us see. Electric field, steady charge, but when charge is moving, it having magnetic field. So when charge is moving, it having two kind of fields, electric fields and magnetic field. So let us see, if we add the electric force and magnetic force, then we will have new equation. Let us see. Okay, see, means when charge is moving, that moving charge is under the effect of both fields, that means electric field and magnetic field. So we will have the total force acting on a charge is given by F is equal to F electric field plus F magnetic field. Now we have already seen what is the equation of electric field, that is Q multiplied by E plus equation of magnetic field Q multiplied by V cross B. Okay, from this what is common? Take it out. Q is common, so we will have F is equal to Q. It is common, in bracket what will remain? E plus V cross B, right? So this is the equation of total force due to the moving charge, and this equation is known as equation of Lorentz force. Dear students, this equation is very much important, right? Why? Because in any, it can be asked as a 1 mark question or as an MCQ question, right? If it is asked in MCQ question, so what should be the question, right? So question is like this: which of the following force is velocity dependent force? So your answer will be a Lorentz force. Why Lorentz force? Because see here, F is equal to, here there is a term velocity. So F is directly proportional to that velocity, means F, this force, it depends upon velocity V. So Lorentz force is velocity dependent force. From this equation we will come to know few points. Which points? Let us see. So this force, Lorentz force, it depends upon which? It depends upon Q, that is electric charge. It also depends upon V, that is velocity of that moving charge. Not only that, it also depend upon magnetic field B and electric field itself, the charge having. Okay, so the Lorentz force depends upon Q, V, B and automatically E also. Second point, right? This magnetic force means Fm is equal to Q V cross B. Okay, there is a cross product between velocity and magnetic field, so you can put sine theta, that is Q VB sine theta. Let us take case number 1. If we will take theta is equal to 0, right? That means put theta is equal to 0 here, so you will get sine 0. Sine 0 is equal to 0. If theta is equal to 0, that means velocity of a charge and magnetic field both are parallel to each other. Means theta is equal to 0 indicates that velocity is parallel to B, magnetic field. So in this situation, put theta is equal to 0, sine 0 is equal to 0. So entire term becomes 0. Means this magnetic force Fm becomes how much? 0. Got it? So magnetic force is 0 when the velocity is parallel to B. Or you can say that the velocity of a charge is 0. So there is one more condition. Magnetic force is 0 when velocity of that charge is 0. It means the charge is steady, and steady charge do not produce magnetic field. Steady charge produce electric field only, right? Okay, good. Let us see case number 2. If theta is equal to 90, if theta is equal to 90 means velocity of a charge is perpendicular to the magnetic field. Means magnetic field will be the parallel to the plane. Parallel? No. Perpendicular to the plane means magnetic field like this, and charge is moving perpendicular to each other. Means the velocity of charge and magnetic field both are perpendicular to each other. In this case, sine 90 and sine 90 value 1. So put sine 90 in our equation. So in this case, that magnetic force Fm is equal to QVB, and this magnetic force is maximum, and the direction of this magnetic force is perpendicular to both. Perpendicular to both means, let us see how. Suppose the charge is moving in this direction, means the velocity of a charge is in x direction. Magnetic field is in, suppose, z direction. So it is the direction of magnetic field. Let us see. As per our case, velocity of the charge and magnetic field both are perpendicular to each other. When velocity and magnetic field are perpendicular to each other, then according to the equation, the force is maximum, and that maximum force acting which is perpendicular to the both, that is Fm. See here from the figure, this magnetic force is perpendicular to the velocity of the charge. Not only that, it is perpendicular to the magnetic field also. Check it out. Okay, so this is end of today's topic. That means electric field due to steady charge, but when charge is moving, it having magnetic field. Then total force. Total force, it is known as Lorentz force. So what is Lorentz force? Algebraic sum of electric force and magnetic force, is known as Lorentz force. Put the equation of electric force and magnetic force, you will have the Lorentz equation. And here you have to remember that 2 points. Which points? That Lorentz force depends upon charge Q, velocity V, and magnetic field B. This is second point, means here we have taken only magnetic force. So what is magnetic force? Fm is equal to Q V cross B. As there is a vector product, then you have equation of magnetic force, and the equation of magnetic force is QVB sin theta. Then we took two cases. Theta is equal to 0, that means velocity of a charge is parallel to that magnetic field, so at that time the magnetic force becomes 0. Or when velocity of a charge is 0, means charge is steady, then magnetic force is 0. Then second case, if the velocity of a charge, suppose this is a charge and it is moving in x direction, then magnetic field, obviously it is in z direction, both are perpendicular to each other, then magnetic force produced which is perpendicular to both means velocity of a charge and magnetic field, and this magnetic force is along which direction? Y direction. Okay, so this much thing you have to remember, and it is there on page number 134, 135 in our physics textbook. Right? After watching this video, you must have to refer textbook, and then you have to write few points in your notebook. Thank you.